Welcome to ZKast, everyone. I'm Zeus Caraval from ZK Research, and I am here joined by a return guest, Bob O'Donnell from TECHnaysis Research. Bob, happy to have you back. Why don't you just do a quick intro to yourself?
Yeah, thanks, Zeus. It's great to be back again. So, Bob O'Donnell. I've been a tech industry analyst for longer than I care to admit, covering a lot of companies all the way from the chip and semiconductor manufacturing side up through PCs and now generative AI, 5G, all that good stuff. And I write for a bunch of places, USA Today, Forbes, and LinkedIn. Yeah. I just started doing a column for RC Wireless for 5G infrastructure.
Oh, cool. And you are you're not as siloed as many analysts, so I like talking to you because you get to connect the dots between a bunch of different things. And there's perhaps no company that connects more dots than NVIDIA. And of course, they just had their recent GPU technology conference, also known as GTC. The last one that's going to be virtual, according to Jensen, so I'm glad it's coming back live.
Yes, exactly.
But it's always a fascinating show because, a lot of the events we go to, there's a lot of here and now, but NVIDIA is thinking about stuff a year from now, 5 years from now, 10 years from now. And I just wanted to get your, general thoughts from what you thought of the show.
Yeah, no, I mean, look, I've watched a lot of Jensen keynotes over the years at various events, and he did he's obviously very well coached, but he also exuded a certain joy. I think he knows that the company's in a moment because, of course, the moment today and now and has been and probably will be for a while is generative AI and chat GPT in particular. And almost all of that work is being powered by NVIDIA GPUs. And, it's been fascinating to watch the company evolve over the years from, basically, hey, these are chips for gaming systems, which is cool. And then into gaming consoles, which is cool. And then they got into cars, which is cool. And now, though, they've got the data center and supercomputing and all kinds of really fascinating stuff. And what's to Jensen's credit in particular, Jensen Huang being the CEO, early on, they kind of fell into it, to be fair. I don't think they necessarily went out of their way, but they found out that people were using their GPUs for general purpose computing applications. So they started calling it the GPU, general purpose GPU, as opposed to just for graphics.
Right.
And, they did all this interesting work early on with machine learning. And initially it was about being able to tell a dog photo from a cat photo and kind of very basic stuff now when we look back, but it was setting the groundwork for a lot more. And then they developed CUDA, which is their, development framework to be able to create applications for these general purpose GPUs. And initially they got a lot of grief because it was like, oh, it's proprietary and what have you. Well, they've continued to evolve it. Academia rapidly accepted what they were doing. And that in turn led to an explosion of commercial applications. And now here we are in 2023 with this explosion of generative AI. And not only that, but also digital twins and 3D modeling. Again, that pulls back in the historical side of NVIDIA from graphics and doing 3D graphics initially for games. Now they're doing 3D graphics to model factories and create digital twins and make all this stuff work together. So they have really pulled together a pretty impressive vision. And as I know we're going to talk about, now moving beyond just designing the chips and some of the systems, but now even moving into cloud-based services, which is crazy to me to think they're going to do that, but it's a very, I think, interesting and smart move.
Yeah. A lot of people think of NVIDIA as the GPU graphics company or the AI company and stuff, but what they are, in fact, is an accelerated computing company. And whatever workload you have that's too difficult for CPUs only, Jensen always jokes that the more you spend, the more you save, which is true for a lot of the workloads they deal with. If you think about, like, they gave an example of AT&T just using their stuff for route optimization, something that took 6 hours took 3 minutes, right? And so, CPUs are great for certain things. It's what Jensen sort of jokes. It's like something's got to open Word, but it's not. They're not really great for anything that requires parallel. Where you need to push a lot of traffic through and do a lot of analysis. Now, and I thought this show really demonstrated this, Bob. One of the things that when I read about NVIDIA, there are people that love the company. You'll talk to Wall Street guys, a lot of bulls, and there's a lot of bears. And people think that Intel's coming, AMD's coming, and they're going to take a chunk out of what NVIDIA does. And, we talked a bit about this in our prep, but I think what really makes NVIDIA unique isn't the silicon. And you can argue, do they have better silicon than other companies? I think they would say they do. But it's really the ecosystem that they've created around themselves through their systems approach. So, when you think of, the GPUs in cars, they don't sell GPUs, they sell the drive system that includes the server and all the memory and all the software, right? They sell Clara for MRI. They sell Omniverse for digital twins, right? And so it's this kind of end-to-end engineered system approach that actually lets them win. And I know, you've got some thoughts on this too, but they did take some criticism for it early on, but that has become their big differentiator.
Absolutely. No, I think you're right. And look, I do think we are going to see, obviously, both AMD and Intel in particular continue to advance what they're doing. I mean, AMD in particular obviously has both GPUs and CPUs, and they're leveraging that. The interesting point, by the way, and NVIDIA does not get a lot of credit for this, but they're starting to develop ARM-based CPUs as well. People may recall that it was NVIDIA that wanted to buy ARM.
Yes. Yeah.
And the reason they wanted to is because they've been working on designing these CPUs. And so now they have these Grace Hopper CPUs that are ARM-based that they pair along with their GPUs. So, they're combining these elements together, and now they're creating supercomputers. And the interesting point, as you said, they're actually taking it all the way to building complete servers. I mean, you don't see Intel selling a box. And yet NVIDIA has built these boxes, and they actually sell, and now they lease them. Of course, they have partners who build them as well, like any other major semiconductor company. But to your point, and what I think they recognized was like, hey, we're the best equipped to do some of these things on the software side. So let's just do this. And then we can kind of show the world what can happen from it. So they have this Isaac platform for robotics. They have, to be honest with you, they have so many names and platforms, I can't even remember them all. Like you said, Clara for health. They have,
it's funny.
they have all these different things. And now what they're doing is not only have they been helping other large language models, these foundation models, they were early on with foundation models. They recognized, hey, again, general purpose GPU compute need a lot of parallel processing, and that's what GPUs are good at, doing lots of simple things all at the same time. And so they started building some of their own large language models. And what was really fascinating to me at this show was, hey, they're releasing their own models, right? So they have Nemo, which is their large language text model. They have Picasso, which is their image model. And then they have Nemo, BioNemo, which is for molecular and drug discovery and things like that. So they're actually building models that theoretically some could argue are a competitor, or an alternative, at least, to ChatGPT and what Google's doing with Bard and Lambda and some of their models. But on top of that, now they've also built these services. So they've built Omniverse for digital twins and the ability to create your own digital twins. Now they're actually going to offer that as a service through the cloud guys. So they said, look, we're not a cloud company, to be clear. They're not going to set up, all kinds of data centers all over the world. But what they're going to do is sell this as a service on top of the services from AWS and Google in particular, they really emphasize, but also Azure, and not quite as much on AWS. We'll see what happens. But Google and Azure in particular, they talked about partnerships. And I imagine, obviously, they're going to do some AWS as well. But it's amazing because now all of a sudden, here's yet a whole new revenue source for the company, a whole new go-to-market model in a way, and a whole new set of capabilities. Now, will companies choose to use them as opposed to, other services that, obviously Google's going to probably offer on their own, and Azure and AWS will? I don't know. It's going to be interesting to see. But man, I got to give Jensen credit. I mean, this is a big step forward for them.
Yeah, but don't you think it democratizes, it's all about choice, right? So customers,
Yes.
if you want to just go grab, the open AI models from Microsoft or whatever off Azure, you can do that, or you can use more of a complete system from NVIDIA. And I think one of the things that's limited NVIDIA's growth, that's hard to say given how much they've grown, is the fact that you do have to be the biggest of the big in these very technically, mass general size hospitals and things like that to use the stuff. By having it out of the cloud, no, everybody can have access to it. In fact, your upfront investment goes from like hundreds of thousands to nothing.
Yeah.
Right. And so, I know you asked them on the Q&A with Jensen about the revenue model. And just, for our audience, were you happy with the answer you got? Like, what do you think this does? Like,
I mean, he obviously, Jensen's good at sort of politically answering questions, in that he'll give you a little bit of what you want, but not quite everything. Then he'll go off on a different tangent. But that's fine. He's always kind of done that, and that's just the way he is. But I mean, he did at least address kind of one of the core questions I asked, which was, hey, does this mean you're going to actually have a sales force that's going to go out to corporations and offer your services? And he said, no, it's going to be a co-selling effort. But it does imply, again, I think, a whole different side of the business that we haven't really seen NVIDIA do. Now, the interesting thing I will say, not everybody knows about this, but GeForce Now is a cloud-based gaming system. Everybody in the past was talking about Google's cloud-based gaming and other companies. Nobody's really sort of done much. The only one that's actually still pretty much in existence that I know of is GeForce Now. And in that sense, NVIDIA actually had to set up data centers in the US. In other parts of the world, they're selling GeForce Now through carriers. So I think they have Vodafone in Europe, and they have a bunch of other carriers around the world. They couldn't get the US carriers to kind of bite on it. But instead, NVIDIA actually set up their own data centers just for GeForce Now. What it does is essentially, even if you have a old crappy PC or even a Chromebook, whatever, you can essentially rent a high-end GPU in the cloud to run games from any device. And they actually did build that infrastructure. So there is a part of the business that has that. A lot of people know about that. Theoretically, they could start to leverage some of that to deliver some of these services. Although he did make it clear, look, we're not going to be a cloud computing company. So that's a long-winded answer. Did I get an answer that I thought was satisfactory? It was enough to give me a sense of where they're headed, I think.
Yeah. Now, I'll shift gears here a bit from the cloud. One of the comments that Jensen made pre-GTP, though, GTC, was that ChatGPT was the iPhone moment for AI.
I think he said it like 4 times in his keynote, by the way.
Yeah. And do you agree with that?
I do. I think it is. Here's the deal. What we have seen with ChatGPT is just all of a sudden kind of like the blinders came off for people, like, oh my God, like, look what this can do. And yes, there are obviously a lot of challenges and concerns, and there's huge questions on ethics and going off the guardrails and safety, and there's copyright issues. I mean, there's a lot of stuff to figure out, but the overwhelming impressiveness of it and the number of people who have now seen it are just completely blown away makes it pretty clear that I think this is really changing. I mean, I don't know if you saw, Bill Gates just did a long blog on it that I read as well. And, his perspective was, this is a radical change. This is not, some weird Bitcoin phenomenon that's like, yeah, who cares? This is like the real deal. This is going to dramatically change the way we think about computing. And I think it's true. And I think we are seeing this. And there's going to be all kinds of questions, back to the comment about the models. Like, do people want to use one foundation model and then customize it? Or do they want to have multiple foundation models for different applications? And which kind of companies do they want to work with for this? Those are all big questions, I think, obviously remain to be seen and probably won't be answered for several years. But I do feel like it's a moment where people are recognizing there's a new way of working, a new way of doing stuff. I think Microsoft, by integrating it into, Office, Microsoft 365, Office 365 apps, Google with them putting it into their workspace apps, obviously starting out just with Docs and Mail, but it's going to change things, I think, pretty dramatically.
I do wonder, without ChatGPT, would we be seeing the flurry of generative AI announcements that we're seeing now? And
it's a fair question.
There's going to be a ton there. I kind of agree with the statement, but in some ways, I don't. Like the iPhone itself didn't really democratize smartphones. It was just all the apps and stuff created on top of that, and the ability to democratize. And actually, I think NVIDIA is the company that could actually help take ChatGPT from being kind of this geeky thing to something that is fully democratized, at least part of the ecosystem. But I do wonder if people really know what to do with it. I just got back from the Adobe Summit as well this week, and they've loaded up some of their digital marketing stuff with generative AI, but they also understood that people wouldn't know what to do with it coming out of the box. They created a lot of sample emails and graphics and things like that. And then, so if they showed an example, if you're from, General Motors and somebody likes the beach and they're a Cadillac customer, create a Cadillac on a beach, right? That sort of thing. And it can create that graphic for you. And I think that's a great way. When I talked to Adobe about it, I said, I thought that was a great way to prime the pump, right? Because once you've got those examples out there, then that gets the creative juices flowing. So I think it got the vendor community much more interested in generative AI, which will then create kind of the iPhone explosion that we saw. But clearly, we're not going back. Right? So.
Yeah, no, exactly. And look, to be clear, I think when we define it as an iPhone moment, I don't think of it as a product moment. Yeah. Some people I think are too focused on the product moment side of things. When I think of it as the iPhone moment, I think of it as an architectural change where computing went from being only on a PC to on a device that we carry around with us. I mean, the apps were a part of it, but even above that, it's the nature of how computing changed, because all of a sudden we had a computer in our pockets, to use the old, analogy that's been killed by being used so many times. But that's really what happened. And that's how I think of the iPhone moment. So in that regard, I do think the generative AI stuff is that kind of moment, because it changes the architecture of how we think about doing things. It's different. It's not it's not a perfect analogy to iPhone, but I think the point is that was seen as a step change. Like a lot of things changed after that. I think a lot of things are going to change after this. To your point, the UI on this stuff is horrendous, right? I mean, it's like you're staring at a blank. Like, how am I supposed to put the right prompt in there to get what I want? And I've already seen, there's already been some work done on the fact that you can, the exact same tool, not even Chat GPT 3.5 versus 4, but within 3.5 or within 4, within, Bard or any other of these tools, it's the quality of the prompt that you have to put in that determines the quality of the output. So people have to be trained. How the hell do I create a good prompt? And so that's where there's a lot of work that's going to have to happen.
Like in the Adobe's case, they created a whole low-code, no-code interface that masked the complexity of it. And so, you think the same thing happened with the App Store community, right? All of a sudden, you didn't really need to be anybody can create an app for an iPhone today, right? Where you think in
yes,
the BlackBerry
no.
days, huh?
But I mean, look, sorry to cut you off. No, I think you're right, but you still have to be a programmer, right?
Yeah.
I mean, one of the other crazy things about this whole Chat GPT and OpenAI thing, low code, no code really becomes low code, no code, because look, even low code, no code stuff, you still had to know programming principles. I couldn't sit there and say, but I could have an idea to say, hey, I want an app that does X, Y, and Z. And literally me just saying that, or typing it in this case, it'll generate, it starts to generate code that does that. That's really a dramatic moment in terms of, I think the low code, no code world, and I've written on this, I think is going to actually be one of the biggest benefactors of generative AI. I think it's going to impact a lot of things, but that is one.
It'll actually make it no code.
Yeah, it's no code. Like, it's idea generation. And the other thing that this is I call this content synthesis. So I'm I'm a music guy. I used to be the editor of Electronic Musician and Music Technology magazines. I have a lot of music synthesizers. I've always been fascinated. And these are content synthesizers. I mean, they take raw materials and then just generate this amazing stuff from them. And it's really pretty interesting. I mean, it is a little crazy scary, and I'm not getting into artificial general intelligence kind of discussion, because that's a whole separate thing. But just for now, the ability to crank out these things, but it needs to be powered somewhere. And then, one of the questions moving forward will be, hey, what if I have an NVIDIA GPU on my PC? Can I start to run these models even locally? Obviously they'll be cloud-based, but then eventually in a private data center and even on clients. Qualcomm showed a very simple version of that at MWC, running DALL-E, or one of the image generation tools, on one of their phones. So it's going to rapidly evolve and go to a lot of places. And again, a reason why NVIDIA is well positioned, back to our original discussion, is, look, they've got chips in PCs, they've got chips in private data centers, they obviously have chips and now even services in the cloud. So they're very well positioned to leverage what they have across a lot of different places.
All right, so let's talk product announcements then, because the show is filled with them, and we're certainly not going to talk about every one of them. But so let's each pick three and do a little round robin. For you watching, everyone watching, I'll include a link to the press release in it, so if you want to follow up, you can. So I'll go first. The first one I really liked, and it kind of flew under the radar because of all the other news, was the partnership with Medtronics, and the way they used Holoscan, which is another one of these NVIDIA pre-configured kits, which is specifically created for the medical industry, to actually do more intelligent colonoscopies. And I think it's funny, when I talked to Mass General about the first use of Clara for MRI, and the doctors at first were kind of opposed to it, right? They didn't really want an AI looking through MRIs because they thought they could do it better. And then the doctors realized, lo and behold, it can see things I can't see. And I think so the announcement itself was kind of interesting, right? With Medtronic, they can do smarter colonoscopies, but I think it's more the implication of what the impact AI can have on healthcare. There's a lot of people that get sick or get cancer, and early detection had been better, they would have been able to be saved. And I just think it's not something we do very well today with all the technology we have. I don't know why every medical checkup you have, that data is not run through some kind of AI engine to connect the dots and see what's going on, because the information's there. And so I think the work NVIDIA has been doing in healthcare is just like, I don't want to overstate it, but it is life-saving, right?
No, it absolutely is. And I could not agree with you more. I think it's fascinating. Some of these things may take a while, in drug discovery can often take years before we really see the benefits of it. But some of those things, like you said, can be immediately applied. It's a question of companies and doctors and hospitals' willingness, and the medical industry in general, their willingness to accept these tools and use them. And of course, obviously, you have to be careful, because remember, there were early experiments with this. Remember, IBM Watson Health, that they were going to do, ended up actually not doing a very good job of reading X-rays and some of these types of things. But obviously that was a long time ago. Yeah. Things have advanced tremendously. And now I think they're seeing, they're finally, basically, we're now delivering on the promise of those sort of early ideas. The ideas before were good. Now it's the delivery of them.
All right. So now you go with what?
Yeah. So, I mean, I'll start with the Omniverse Cloud, because, again, this notion of a company like NVIDIA actually offering a cloud service that's sold on top of and alongside an existing cloud company is kind of a different kind of a model anyway, but particularly coming from a company whose primary business is designing semiconductors. It's kind of crazy to me that that's what they're doing, but it is. And the other thing about it is, what I find fascinating is it leverages, of course, all this 3D modeling work and digital twinning work that they're doing. And, they gave a great example. So they're working with BMW, and they are literally building a digital twin of a factory that's going to be physically online in 2025, but they're doing it now and they're running through all of it. And they're literally putting every single machine in and designing everything, the flow of parts through the factory. And they're doing all of this it's a digital simulation, hence digital twin. And theoretically, that's going to save a huge amount of time and money when it comes to the actual physical production, because theoretically any glitches that pop up, and they, apparently do all the time in these kind of big projects, will be resolved because we'll have figured it out in advance. So I think that idea has a lot of implications for manufacturing, obviously for cars and super sophisticated manufacturing, but even for simpler things, I think it could be very interesting, and other types of applications and environments as well.
Yeah, I was actually going to mention Omniverse too, but I just think the use of digital twins is going to explode. I've talked to stadium owners that want to use it to model how people traffic and how people go through, through the park, and how, with retailers trying to figure out how the best way to lay out stores and stuff. So I think that's going to be huge. So since you went on Omniverse, my second one, Bluefield III, and I think this was, it was one that I didn't think got the attention of like an Omniverse or something like that, but Bluefield is their data processing unit and takes their systems approach, I think, to an entirely another level, because they bring in the aspect of networking, right? So they bought Mellanox, they bought Cumulus. And so Bluefield III is a networking device with a GPU on it. It's a big card, actually, that you stick in a computer, and it offloads all the heavy lifting. And so there's certain things PCs are good at, right? And there's other things, encryption, data processing, things like that that it's not. And so as a cloud provider, even as an enterprise, if you can offload all the heavy lifting from your server to this DPU, you can actually have that server do a lot more stuff. And I know that the thing that's held companies back historically from using DPUs is just the high cost of them. But the cost of it is small when compared to having to buy a whole bank of servers.
Right.
So, it's something that, they announced Oracle Cloud would be using that as their part of their cloud form. But I really like the DPU announcement because it is this kind of ultimate system of, GPUs, CPUs, InfiniBand in there that connects the things together. And I think will allow servers to, take a step level and function in capability, because they're not doing things they're not supposed to do.
Yeah, no, it's great. And, one of the challenges, of course, is unfortunately we've got lots of different XPUs that people are using, and NVIDIA uses DPU. Intel calls theirs an IPU, an infrastructure processing unit. But it's a similar kind of thing where, as again, to use another Jensen analogy, he's always talked about, if you look at a server rack, it's north-south traffic has been, between the servers and the CPUs. There's been a lot of work there. But the east-west traffic, that is from one rack to another, has been a challenge. And as the processing demands have increased for things like these huge large language models that need massive numbers of servers, the interconnection between those becomes critical. And that's exactly what their, the Bluefield stuff is optimized to do and deal with that. And like you said, it's not as sexy as some of the other stuff for sure, but I think it really is important.
Yeah. Okay. And what's up with you?
So for my next one, I would say, the Grace Hopper super chip, it's not technically new because they had just mentioned it before, but I think, I believe, if I remember correctly, they have said it's officially now shipping, or it's about to be shipping. And that, combines that ARM CPU and their GPU into one single system. So literally, it's almost like a supercomputer on a card kind of a thing. And, again, the implications of that, I think, are going to be profound, because you're going to be able to see levels of performance that are way beyond what we've seen. The other thing it starts to address, although not completely, is the fact that one of the sort of dirty little secrets of all this generative AI is it takes massive amounts of power, like staggering amounts of power. And so that's an issue, right? You can't just be sucking down all the power to generate, clever made up poems from ChatGPT. So obviously it does more than that, but you get my point.
No, you're right. In fact, Java Khan, the GM of WebEx, said that on our pre-brief this morning, right? That the AI stuff isn't free. Right?
No, it is not free, especially from a power perspective. So I think we're going to see a lot of innovations around power reductions. I mean, GPUs, unfortunately, are huge power sucks. So that is an issue, and they're going to have to figure out how to get more power efficient there. But by leveraging ARM, they're able to do something there on that side. So I think that, to me, was also a pretty cool one.
Yeah, the other one I'll mention is Kulatho, which is what Jensen led off with, which is interesting because they are a chip manufacturer, not a chip designer, although you could argue with ARM they are, I suppose. So, but what Kulatho is, it's a kind of a new set of algorithms that accelerate the underlying calculations of computational lithography, which is the process of printing chip design on silicon. So I don't remember kind of anybody trying to innovate in this space before. So, but they've apparently come up with a whole new way to do it. So, but there's a bunch of stuff I didn't understand, like inverse curvilinear masks and things like that. But in essence, what they've done is they've used their own smarts, I guess, to come up with a better way of printing chips to allow us to actually get more density on a CPU, which I guess staves off this, the death of Moore's law.
Right. I mean, and it is fascinating. And I mean, I think there have been work done in some of these areas, but it's just not something we ever hear about, right? Because it's, it's very high level stuff. But it was, I have to say, and I even tweeted to this effect during the keynote, the demo they showed of this cuLitho was probably the best explanation of what's called EUV, extreme ultraviolet lithography, which is the high end stuff like that they're doing to get the smallest chips. You hear about 3 nanometer, 2 nanometer, and sub 1 nanometer chips. You can only do that with these what are called the masks that lay out where the circuits are supposed to go and all the lines on there. Super hard to do. And so it's sort of a meta case of chips, creating software to help design better chips. And theoretically, NVIDIA themselves benefit because now some of these processes can be used to generate, smaller nanometer size chips for GPUs as well as CPUs. So I thought that was, I thought that one was very cool as well. And honestly, I was thinking about using that one too. So I don't know if I have a third one.
All right. Well, maybe this has gone, we've gone on quite a ways. So that's probably a good ending point. I will say the one thing Jensen did say though at the beginning is this is the last virtual one. They'll be back live next year in person. I fear though, his comment said that San Jose is not big enough. San Francisco may not be big enough, which leads me to the conclusion. Vegas. Yeah.
We were both thinking the same thing. I know.
So perhaps next year I'll see you in Vegas, which I guess why not just adds to the number.
I was just saying, just be yet another show in Vegas now.
Yeah. So, but it's the fascinating thing though is GTC has reached that point though.
Yeah.
Right. Where it's not a kind of a geeky show for gamers anymore.
Yeah.
It has become kind of an industry show for all things accelerated computing, much like Cisco Live is for networking or AWS reInvent is for cloud, right? It's now an industry show. And I think that just kind of shows where we are with the video.
That's a great analogy and a good point.
Yeah. So anything else you want to add here, Bob?
No, hey, look, it's great chatting with you as always. Yes.
Yeah, it's always a pleasure having you, Bob. And so on behalf of Bob O'Donnell, I'm ZS Caravella. Don't forget to hit the subscribe button, and I will see you next time on another ZKast. Thanks for joining today, Bob.